Hey everyone, welcome back, and today let's solve Leetcode problem 3011 titled Find if array can be sorted, the daily Leetcode challenge problem for the day. So we're given a zero-indexed array of positive integers nums, and in one operation we can swap any two adjacent elements if they have the same number of set bits, and we're allowed to do this operation any number of times, including 0. And we can return true if we can sort the array, basically meaning after we basically apply some number of operations, again it could be 0 if needed, if we can sort the array after that we can return true, otherwise return false. So in example 1 we have the input array nums to be 8, 4, 2, 30, 15, and we output true. Why is that? They give us a pretty lengthy explanation. Why is that? First let's look at the binary representation of all the individual elements in our input array. So 2, 4, and 8 are all going to have one set bit each, and the binary representations of these numbers are going to be 10 for 2, 100 for 4, and 1000 for 8, right? The numbers 15 and 30 are going to have 4 set bits, each going to have a binary representation of 15 is going to have a binary representation of 1, 1, 1, 1, and 30 is going to have a binary representation of 1, 1, 1, 1, 0, right? And we can essentially sort this array using 4 operations, right? The number of operations we're going to need to sort this array is going to be 4, right? First, we can swap nums at 0 with nums at index 1. Why is this valid? Because 8 and 4 each are going to have one set bit each, and the array would then become 4, 8, 2, 30, 15. Now, then, from here, we can swap num1s with nums2, right? Nums at index 1 with nums at index 2. And why is this valid? Again, because 8 and 2 each also still have one set bit each. And now the array is 4, 2, 8, 30, 15. Then we can swap nums at index 0 with nums at index 1 again. Why? Because this is valid because, again, 4 and 2, the current values that we're swapping, still have exactly one set bit each, right? And the array would then become 2, 4, 8, 30, 15. And finally, we simply have to swap nums at index 3 with nums at index 4, right? 30 with 15. Why? Because 30 and 15 each are going to have 4 set bits, and then the array would become 2, 4, 8, 15, 30. And although we took 4 operations, it doesn't really matter. The array has become sorted after some number of operations, and so this is going to be a true output. We can sort the array on the following rules of how we can actually swap elements with the same set bits. Okay? So looking at example 2, we have the input array nums to be 1, 2, 3, 4, 5. We don't really even need to do any operations on this with equal bit values because it's already sorted, right? 1, 2, 3, 4, 5 is already in ascending order, and so we can immediately return true. However, in example 3, we have the input array nums to be 3, 16, 8, 4, 2, and regardless of what combination of operations we try, we cannot actually sort this input array using any number of operations with equal set bit values, and so for that reason we'd output false for this example. So with that out of the way, I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so how can we kind of optimally solve this problem? So first of all, I just want to keep track of the number of set bits or ones in my previous integer's binary form as I iterate through my input array nums, right? And I'm going to have a previous max. What is that going to do? It's simply going to store the maximum value found in previous groups or windows of integers with the same number of set bits as my current. And I'm going to have a current maximum and a current minimum. It's pretty self-explanatory. They're going to track the maximum and the minimum values of all the integers within the current group that have the same set bit values, right? And as we iterate over each value in our input array, we can convert it to its binary representation and simply count its set bits. And when the number, right, the current number that we're looking at, when it has a different set bit count than the previous one, we know we've kind of hit a new group. So then, from there, we can compare the previous max, which is again the maximum of the previous group, with the current minimum, the minimum of the current group. But If the previous max is greater than the current minimum, which again, that's going to be the maximum of the previous group being greater than the minimum of the current group, then we have to return false. Why? Because the array cannot be sorted according to that rule, right? It's not even less than the previous element. But if all of these conditions are actually true, we can move on to the next number and continue doing these operations until we traverse through the entire input array nums. Right, so with that out of the way, let's just go ahead and dive straight into the code here. And like I was talking about before, I'm going to have my previous, I'll just call it set bits, and it's going to be initialized to -1. Why is that? Because it's simply a placeholder to again store the number of set bits of every single previous integer in our list. And it's going to help us know when we actually hit a new group based on the set bit count. And then we'll have a prev max, sorry about that. And it's going to be maximized to the float, minimized of the float of -infinity. I think that's how you do it in Python. Yeah, I think the subtraction is within the string. I think so. I might get an error. We'll see how that goes. What is this going to do? It's simply going to represent the maximum value in our previous group, right? And that makes sure that in our first iteration, any integer we encounter is going to be greater than its previous or initial value. Now, like I talked about before, we're going to have a current maximum and minimum values. Current max is going to be minimized to the float of infinity, the float of -infinity, and the current minimum, should add 2 R's, it's fine. It's going to be the float, again, maximized to the float of positive infinity. What is these variables going to do? It's simply going to track the current group of numbers within the same bit count, the maximum and minimum values in this current group or window of numbers. Now we can start iterating over our input array nums now that we've defined these variables to keep track of our each value's set bit counts in each of our windows. So I'm going to say for num in my input array nums, okay, as we just iterate over all the different numbers, now we have to initialize our set bits value. What is this going to be? It's going to be bin, I'll explain this later on, it's going to be bin of our integer num, or rather our iterator num for this current value, dot count of the string 1. What does this actually mean? It's simply going to calculate the number of set bits, or ones, in the binary representation of num. What does bin of num do in Python? It simply just converts num to its binary representation and counts basically the number of ones, or the strings of ones, in this binary representation of that string, right? Now that we've got our set bits kind of count, now, if the set bits, what is that? Set bits is simply going to store the number of occurrences of ones in the binary string representation of our current value or integer num. Now, if the set bits is not equal to the previous set bits, right? Pretty self-explanatory. If the current number's set bits is different or not equal to the set bits or the previous set bits of the previous value, that means we're in a new group of integers that have a different set bit count. So what do? Now we have to check, okay, if the previous max is actually greater than the current minimum, right, like we talked about before, sorry, I forgot my underscore, then we have to immediately return false. But why do we have to immediately return false? If the maximum from the previous group is greater than the current minimum of the current group, we have to return false because that indicates that the array cannot be arranged according to that required sorting rule, right? And once we do that, once we check for that case, now we can again initialize our previous set bits, or rather update it to be equal to our current set bits, right? Because we're moving on to the next integer num in the next iteration, right? We're kind of entering a new group. And then we can set our now prev max to be, then we can now update our prev max now to be our current max, right? Why is that? We're simply updating our prev max, storing the maximum value of the previous group, right? Which is going to allow us to separate values within our different groups. Once we do that, now we can also update our current minimum and maximum. Our current maximum is going to be now equal to the integer value num, and our current minimum, well, you guessed it, is also equal to num, right? Why is that? Because it's the first number in this new group. And they're initialized to this number because, again, it's the first number in the current new group that we're entering. Now, if our set bits is not even equal to the previous set bits, I'm going to have an else condition for that. If that's not the case, I want to then set my current maximum to be the maximum value of my current max and my integer value num. We don't want to make it smaller, and we have to have our current minimum set to the minimum of course, itself, because we don't want to make it bigger, and the integer value num that we're currently using to iterate at this current iteration, right? If the set bits, again, what are we doing here? If the set bits is the same as the previous set bits, if we haven't entered this conditional, then we're still in our current group. So what do we do then? We have to update our current maximum in this current group to be the maximum value between itself and num, because we don't want to make it smaller, and the current minimum to be the minimum value of itself and num, because we don't want to make this variable larger. And once we've done that, outside of this for loop, once we're done iterating through all the values, we can simply return, okay, is our current previous max, is this actually less than or equal to our current minimum? Why do we do that? Because why? Because if our previous max is less than or equal to our current minimum, that means is our array arrangeable, or can it be arranged according to these problem's rules? Can we eventually sort it when our previous max is still greater than the current min, when our current set bits is not equal to the previous set bits count of the previous group? And if that holds true, that means we can actually fit this problem's rules of switching adjacent elements and sorting the array accordingly. And as you can see, if I were to submit this, unless I made any syntax errors here, this should be accepted. I did wrong here. Oh, oops. I forgot to tab these. Sorry about that. Forgot to put all these in the conditional. But now, as you can see, if I were to submit this, it should be accepted. And as you can see, this is just about as efficient as you can get. So what is this code kind of do overall? Let's talk about it. Okay, first, we simply have to examine, can this array be sorted? Why? Based on their binary set bit count of each integer, right? And we essentially have to group integers with the same number of set bits, or the same equal set bit count, and that makes sure that each group's values are organized so that the maximum value from one group doesn't exceed the minimum of its next group that we're entering. And this is going to allow us to determine, is our array satisfying this unique sorting rule of, again, kind of swapping two adjacent elements if they have, again, the number, or rather the same number of set bits, right? And as you can see, what is a set bit? It's simply the binary representation of a number that has a value of 1. Hence the reason why we count how many ones, or the string 1 is equal to the, or rather is in the binary representation of our current integer num, right? And that's basically how this code works. For the top complexity, this is going to be a big O of n, or linear time solution, where n is again the length of our input array nums. Since it's really just a one-pass solution, we're just processing through this array once. We're simply checking each element exactly once. And the space complexity is going to be a constant time solution, big O of 1, because we really only have a few variables, like these integer value variables, prev max, cur max, and cur min, and set bits and things like that, but we're not actually using any auxiliary memory or any extra data structures to store any elements from our input. So for that reason, this is going to be a big O of 1, or constant time solution. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.